In this video, we are going to look at serverless architecture, a model where you stop thinking about servers entirely and just deploy the individual functions your application needs to run. By the end, you will understand how it works, why it exists, and when it is the right tool for the job. When you deploy a traditional application, you rent or provision servers and keep them running around the clock. But most applications are not busy all the time. There are quiet hours, slow seasons, and long gaps between bursts of traffic. During those gaps, you are paying for capacity you are not using, and your team is spending time managing the machines instead of building features. Think about the difference between owning a generator and plugging into a power grid. With a generator, you are responsible for fuel, maintenance, and sizing it correctly for your peak demand. With a grid, power is just available when you need it, and you pay only for what you consume. Serverless computing gives your code that same on-demand relationship with infrastructure. In a serverless architecture, there are no long-running application servers. Instead, the cloud platform provides two types of entry points: an API gateway that accepts HTTP requests and routes them to specific functions, and an event bus or queue that triggers functions asynchronously. Each function is a small, focused unit of business logic. State is never stored inside the function itself. It always reads from and writes to an external managed data store like a database or object storage. Here is what happens when an event arrives. The platform receives it, whether it is an HTTP request, a message on a queue, or a scheduled timer, and decides which function to invoke. If no warm instance of that function exists, the platform must start a new one, which is called a cold start, and adds latency. The function runs, does its work against an external data store, returns its result, and the instance is freed. You are billed only for the milliseconds that function was actually executing, nothing more. Serverless is genuinely excellent when your load is bursty and unpredictable, because the platform scales to zero and back up automatically. But it introduces two significant costs. First, cold starts. The delay when the platform initializes a new function instance can break strict latency requirements for steady, high-throughput workloads. Second, vendor lock-in is real. Your functions are wired to a specific platform's event system, which makes migrating later expensive. The safest place to introduce serverless is at the edges of your system. Things like processing an uploaded image, handling a webhook from a payment provider, or sending a nightly report. These are naturally short-lived and event-driven. As you go further, keep each function focused on one job and never let it hold state in memory between calls. If cold starts become a problem, most platforms let you pre-warm instances at extra cost. And if vendor lock-in worries you, put a thin abstraction layer between your business logic and the platform-specific trigger code. To wrap up, serverless removes the burden of managing servers by running your code as small stateless functions that are invoked by events and scale automatically. You pay only for what executes. The constraints are equally important. Functions cannot hold state, cold starts can hurt latency, and tight coupling to a vendor's platform is a genuine long-term cost. Used in the right context, serverless is one of the most operationally lean architectures available.